Hello everyone, thank you for joining us. I'm Wayne Liu, Tech Lead Manager on the Android Developer Relations team. Today, I will summarize the Google I/O topics covering modern Android development plus build for more screens. Today, under modern Android development, we'll cover the following topics: Jetpack, Compose, and Kotlin. Under build for more screens, we'll talk about Wear, Foldables, tablets, large screens, and TV. Here's a quick summary of all the updates to Jetpack. We have categorized the APIs into alpha, beta, and stable. Alphas are library under active development. Features may be incomplete, but however, everything is tested and highly functional. New in this category is Macro Benchmark, Google Shortcuts, and App Search. Once a library is feature complete, it moves to beta for stabilization. In very rare instances, the APIs may change due to critical feedback from developers. Lastly, we have APIs that are unstable. Let's cover this in the following slides. For CameraX, the latest improvements address feature requests such as exposure compensation, FPS range adjustments, and access to camera state and features. We've also added support for the latest device and OS features, including HDR preview, zoom ratio controls, and support for Android's Do Not Disturb mode. Most importantly, CameraX has continued to address performance, resulting in faster image capture and initialization, especially on older devices. For the paging API, this features a complete rewrite in Kotlin, supporting coroutines and flow, asynchronous loading with RxJava, and Guava primitives, and overall improvements to the repository and presentation layers. We also have the security crypto library, which provides an easy way for you to encrypt files and preferences. Under Fragment, we have performed many stability improvements. This may require work to accommodate the strict enforcement of API contracts. You should pay careful attention to testing. The Fragment release notes calls out more specific details. We have also introduced integration with activity result, making it possible for you to register results from a fragment. For user interfaces, constraint layout, a flexible system for designing layouts, this has reached 2.0. Along with it, MotionLayout is now available to provide rich animation and state management. You can create motion and animation without writing any code, and we have included support for foldables, image filters, and motion effects. Shown over here in Android Studio, Motion Editor gives developers an interactive visual tool for designing animations. And lastly, Jetpack has this new UI toolkit called Compose. This is currently in beta. Compose allows you to describe your UI for a given state and easily update it when the state changes. The latest version of popular Jetpack libraries, including navigation, constraint layout, and many more, these are fully compatible and integrated with Compose. Please stay tuned for its 1.0 stable release in July. Next, let us talk about the state of Kotlin in Android. It's been 4 years since we officially announced support for Kotlin on Android, and its usage continues to grow. And here we have some great apps from the region. For example, Traveloka, Tokopedia, Gojek, Grab, Carousel, Flipkart, Byju's, Swiggy, Zomato, Daily Hunt, and Zoot. Looking at the top 1,000 apps by installs on Google Play, we see that 80% of them contain Kotlin code, and 60% of professional Android developers are now using Kotlin. We also have 4 universities like Chandigarh University, Shivaji University, IK Kujar Technical University, and Gampat University. We also have 2 skilling partners, Learn for Grow and Telangana Academy for Skills and Knowledge. These are all in India, and we are offering Android with Kotlin courses to their students, and we'll be adding many more soon. Talking about Kotlin Gradle, we've made several improvements. Firstly, we have made Kotlin Annotation Processing Tool, KAPT, more reliable and incremental. Secondly, we have landed greater configuration caching in Kotlin. You can now write your greater build files in Kotlin script, removing the need for you to learn Groovy. Another thing that will help you with build times and improve expressiveness is Kotlin Symbol Processors, KSP. We have removed Java stub generation, hence reducing the long build times. KSP directly integrates with Kotlin compiler, providing access to all your Kotlin symbols, supporting incremental multi-run processing, and is ready for multi-platform. The Jetpack Room library has KSP support in beta. Our team has been working closely with JetBrains to address IDE performance issues. In Kotlin 1.5, we are seeing up to 20x faster auto-import suggestions and up to 2 times faster code completion with complex dependency graphs. Make sure to upgrade to the latest version of Android Studio and the Kotlin IDE plugin to benefit from these improvements. Last year, we announced that Kotlin coroutines are the official recommended way to do asynchronous operations. Many of these libraries that I mentioned incorporate coroutines in their APIs, including Flow for observable value streams. We are also working on integrating a coroutines debugger in Android Studio to help you visualize and troubleshoot issues. Finally, I'm excited to share that ART, Android Runtime, is becoming an updatable mainline module in Android 12. We'll now be able to directly update supported language features and add new APIs on future Android devices. This removes the need to wait for a full operating system update. Now that we've covered modern Android development, let's move on and talk about building for more screens. Let's start with what's new in Wear. Powered with the latest chipsets, the next generation of Wear smartwatches will be more performant and power efficient. Additionally, we've optimized the entire Wear OS experience. The apps start up to 30% faster, and the animations and transitions are super smooth. Over the last year, we have launched many new Wear APIs on Jetpack. This includes the latest tiles and ongoing activity APIs. These APIs follow best practices, reduce the need for boilerplate code, and enable you to write code that works consistently throughout Wear OS devices and versions. First, let us talk about tiles. The Jetpack Tiles library is now in alpha, and third-party tiles will start rolling out to users in the coming weeks. Tiles have quickly become one of the most helpful and useful features on Wear OS. They are a great way for you to drive engagement with your app, as the majority of app launches come from tiles. Next, let's take a look at the ongoing activity API. With Wear OS 3, users can easily switch back and forth from the apps they are using. You can navigate back to your app from various places. 1. From other apps. 2. From the home screen. And 3. From the launcher. It creates more surfaces from the watch face for users to see your app. With the Health Services platform, data collection is streamlined into activities and monitoring APIs, health and fitness matrix, sensor and hardware integration. Previously, one of the biggest challenges was preventing excessive battery drain. Now the platform does all the hard work and manages your hardware and sensors. You get more power efficient results with better battery life. Android Health Services is now available in alpha. Next, we have app templates for you to get started quickly. You can use this in Android Studio to create a new wearable project with our templates. You can also pair Wear emulators with your phones directly from Android Studio, so you can start testing and developing the entire experience from end to end. In the latest emulator update, we have improved core features and added a virtual heart rate sensor. Coming soon to Google Play on mobile, users will be able to use search to easily find apps for your watch, look at Wear OS categories for app recommendations. Once users have found an app to try, they can install directly to their watch from the mobile Play Store. Next, let's talk about foldables, tablets, and large screens. For foldables, tablets, and large screens, it's important to build a responsive user experience to scale your UI. Here we cover a list of components to help developers like you do so. Sliding pane layout. This is one of the most common adaptive layouts. And one of the ways is to implement a list detail on the sidebar. For example, a messaging app has a messaging list on the left and message details on the right. The library is now aware and updates to folds and hinges. We have also introduced lock modes, allowing you to control the swipe behavior when the panes overlap. Next, we have navigation rail. This allows you to create a more ergonomic experience across large screens. On a tablet, it supports better reachability. On the phone, users normally hold the phone from the bottom. In apps where vertical scrolling is key, the bottom navigation decreases the amount of content that is easily available to users. To prevent the UI from being overstretched in large screens, we've added max width additions, values to common material components such as buttons, text fields, and sheets. You can now also use the Window Manager library to detect and obtain information on display features, such as folds and hinges. Folds are defined as one continuous screen that can bend. Hinges separate two display areas, splitting the screen into half. Constraint layout. This makes it easy for you to build UI with folds and hinges. With MotionLayout, you can easily simulate different states, flat, half open, and close, and animate the transition between them. With reactive guide helpers, you can inject different fold positions in your layout. To reliably develop foldable features, we have built a testing module for you inside Window Manager to help you write automated tests. You will be able to test experience such as taking your layout into and out of tabletop mode. On large screens, your app may not always be full screen and the window size may change. Hence, we've added new window matrix APIs, current and maximum window matrix, for you to retrieve the correct window size information. Last but not least, let's cover what's new in TV. For TV, we care deeply about the user experience. Hence, we are announcing two new features for you to help build more engaging experiences: the Cast Connect Stream Transfer and Stream Expansion. With Stream Transfer, users can now switch the cast content from another device just by using their voice. With Stream Expansion, users can now add speakers to what is currently playing on the stream. In addition to these new capabilities, we have several tool improvements to help you test and validate your apps. We have added two new emulators for Android 11, one with the traditional Android TV UI and one with the Google TV UI. Next, we are announcing Firebase Test Lab for Android TV OS. Developers are currently running millions of weekly tests for you to evaluate app performance on different devices. Now you can test your apps on a scalable cloud solution without setting up your own physical test lab. This can be done via virtual devices in the Android TV emulator. Thank you for tuning in today to hear about the latest in Jetpack, Compose, Kotlin, Foldables, and TV.